today is very close to each other because we are applying such kind of AI technology to reduce the risk of the for example road users, especially in Thailand, right? So today, in fact, okay, let me introduce about our problem at hand. Okay, let's start with the background. The road accident in Thailand is very big problem. All right, it costs more than 500 billion baht, or about 3% of the country GDP. Okay, according to the World Health Organization in 2019. And I think everyone knows Bangkok is the capital city of Thailand. Okay, so we are going to focus on Bangkok. But it's also the capital of road carnage. Okay, on average, 100 to 20,000 road accidents occur in Bangkok every year. Okay, according to the Accident Data Center of Thailand. And it's the highest number of road accidents in the country compared to other provinces. And then that is statistics in 2021. And you can see this is a Bangkok metropolitan area and number of road accidents compared to other regions. Okay, of course, it's the biggest province and also biggest in terms of the road accident. I want to point out that yes, 90% of road accidents involve motorcycle, okay, in Thailand, especially in Bangkok, right? Because Bangkok is the province with the highest number of road accident fatality in Thailand. That is 1/3 of road accident victims in Bangkok, they are pedestrian. That's why we are focusing on pedestrian in this project. You can see this is a very big news, okay, a few years ago when the zebra crossings in Bangkok become the death traps. The Thai doctor was killed at the crosswalk, okay, by motorcycle crash. That's very sad story. And everyone knows about this. It's a big news in Thailand. That's the trigger, you know, that pedestrian vehicle collisions are the most severe type of accident. So every traffic engineers know about this. Then in terms of the death, okay, average number of fatality is 55 per 100 incidents. That means you have 50% to die in the incident involving pedestrian compared to other types of incident. Yes, every year, okay, in Thailand, on average, 740 pedestrians die each year in road accident. And as I mentioned, 1/3 of them occur in Bangkok. Okay, that is about 2,050 fatality per year. And then most of the accident also caused by the collision with motorcycle, okay, followed by the cars and the trucks. Then let's come to the outline of my presentation today. I want to share our experience on a specific project attempts to use AI to improve pedestrian safety. It's the good start point. We still have a lot of things to do, okay, as a researcher. And then I would like to introduce some applications of AI to improve pedestrian safety. And then I will conclude with what are challenges and future directions. In fact, this project is done under sponsorship by National Research Council of Thailand. Thanks to Dr. Pavini, who initiated these projects, and then invited many researchers into this team. Okay, that's including me, okay, from SIIT, Thammasat University, Dr. Shumket from the Faculty of Architecture, Thammasat University, and also Dr. Narit Nuhom from Mahidol University. Okay, in fact, each has a diverse expertise in the field related to road safety. Especially, I am responsible for traffic engineering part, including some part of the analysis of the risk. Okay, and then Dr. Narit Nuhom, basically he is an expert in computer scientist, so he helped us a lot in developing the prototype for the AI to detect the pedestrian and vehicles. Previously in this session, Dr. Nopadon already gave us an excellent introduction to why we need to assess the risk of accident before waiting for accident to occur. Okay, so yes, with the same concept, we know that to use some surrogate safety measures to assess the accident risk before letting accident occur is very important. To prevent is better to correct, right? Then basically this there are many factors that we need to consider when we collect such kind of data. For example, characteristic may be different by different types of vehicles. That means our system should be able to detect different types of vehicles, right? There are also that lead to different driver behavior as well in terms of speed and then other types of characteristics. Pedestrian also has various behavior. It may, for example, violate, right? They might be violate the traffic law sometime, or they can cross very quickly or without care. Okay, so pedestrian crossing behavior is another area of important research in case of accident risk related to accident to pedestrian. Then there might be several types of pedestrian that need to be detected. For example, a general pedestrians, students, disabled, wheelchairs, or elderly. Especially, there are vulnerable types of road user. And then in such area, such as near the school or hospital, this will be very important. And also physical characteristic of the crossing also very important in terms of how it is configured in terms of measures to prevent the accident, for example, markings or some other measures that I will talk about it later. Dr. Nopadon already gave us excellent information about surrogate traffic measures. For example, we have time to collision and post-encroachment time that can be used to relate to the risk of the pedestrian. When we start this project, we go to the literature review, and we saw research of Dr. Nopadon that really inspires our team. So that means some of our concepts in this study also related to what Dr. Nopadon already mentioned. This is analysis results. Okay, in fact, we collect the data from CCTV in Bangkok. Okay, with the help of the VMA, and then we comes up with the several sites related to several land use. You can see we have several site characteristics. For example, this is a location near the parks in Bangkok. We call Rama Nai Park. Okay, we collect a number of lanes. Okay, types of medians, types of road painting. Okay, some other characteristic like some location in Bangkok, you have a zigzag line, rumble strip, optical speed bar, and as well as the surrounding land use. Okay, the ultimate goal of this research is that we also want to determine the effects of these kind of interventions or environment that might relate to the risk of accidents. In fact, yeah, we separate the work in our team. Okay, basically, that is a team to create AI system to detect the objects. But also, we also need to verify the accuracy of such AI system. Okay, so we also that normally done by manual observation, right? And in this study, we create some tools to help. In fact, it's just a graphical tools to help verifying the data. All right. So we use a quick coordinate system, okay, and then to collect the data from image. And then yes, we also identify proportions, positions, or trajectories of pedestrian and vehicle, okay, using the video footage. This is example of our tools that used to detect the average speed, okay, on the roads by creating the markings, okay, on the video. In fact, this is just a very simple tool. It's not yet implementing any AI. We just use OpenCV based tools in order to manually track, okay, this kind of vehicles or objects in the scenes. But once it's marked, then you can let the system go on, okay, because it will just save the data to the database file like Excel. Okay. Okay, I will switch to next slide. On the other hand, the prototype video-based data collection using deep learning object detector, okay, with tracking algorithm is developed, okay, in this project. It is based on YOLO version 8, okay, with bot sort algorithms. This is example of the, let me borrow the video from Dr. Narit, okay, and team. Then we conduct a pilot study in Thammasat University in order to track the various type of pedestrians and as well as vehicle in Thailand. And with these trained models, okay, so it can be used to track a vehicle to most location. Okay, then we collect data from CCTV and analyze the risk. Right? For example, 85% ties speed, okay, classified by types of passengers, types of vehicles. Okay, you can see motorcycle has a relatively high speed compared to even the passenger cars. It's also various classified by various types of vehicles, okay, and various types of pedestrian. And then we can also classify risk behavior, for example, traffic law violations. You can see motorcycle has a higher rate of traffic law violation compared to other types of pedestrian of the vehicles. Then similar types of analysis using PET or TTC with the speed, okay, is done to classify the event that's considered high or moderate risk. So this is a various site with the different site characteristic. Okay, I will go quickly. You can see they have several configurations. This CCTV show example of traffic violations that we found at the pedestrian crossing, various types of violations. So we also classify different types of traffic violation. Interestingly, not only vehicle that violate the traffic law, you can see the pedestrian also don't care about traffic laws, okay? And many times they cross with the less care, with little care. So let's come to our interesting conclusion in this research as well. This is just an example of the result of the risk analysis. So you can see we can, the limitation of this study is that the number of samples is still very low, okay, due to limitation of the research period of time. So we can only collect a few locations. Anyway, with this only few location, we can see the area or location associated with the high risk, and normally is associated with the high level of pedestrian traffic law violation as well. Okay, and also some relation with the 85% high speed also can be found. For example, when you have a more 85% high speed, then yeah, it's likely that you have more risk incidents in that location. Okay, let's come to conclusion in this project. Basically, we found many problems at the crossing. Okay, in terms of crossing behavior, most pedestrians disregard a traffic signal or crossing. We have a high rate of signal violations. We also provide them with the countermeasure or recommendation, for example, to put more education and raise awareness to pedestrians. Okay, give a better, clear sign or indication of the push button. Okay, there are many locations in Bangkok that provide this kind of push buttons crossing, but most of pedestrians don't care about it. Okay, don't care about it. The driver, in terms of driver behavior, also many driving above the speed limit, and then they don't stop at the crossing during the red light, right? Then that's also possible recommendations measures such as enforcing the laws, okay, clear or pedestrian crossing sign and warning sign, or some other system that can trigger or the drivers to, or even traffic calming measures should be applied or explored as a possible solution in Bangkok. In terms of pedestrian crossing facility, okay, several locations also found that sign and road marking are quite poor conditions or unclear. Okay, and then at the nighttime, we also collect the data at the nighttime. The limit visibility at some location, okay, not appropriate lighting, okay, lightnings, okay, and then it's in fact at the crossing it should be brighter than the regular street light, but we rarely see appropriate lighting in Bangkok. Okay, let me, before I conclude, okay, what's next? Okay, what we have found in the current research, I think including today's, that many researchers share, right? That AI normally can be used to enhance the traffic, especially pedestrian safety in various ways. For example, most of them are used for object detection and tracking, right, in traffic conflict analysis. This is an example of another types of analysis that you can see spatial distribution of where location of high risk, in this case, small PET values, okay, or even by risk location. And normally the tools that is used nowadays, including CCTV and drones. The limitation of drone is that it can be only used at some period of time, not very long. So normally it's used to calibrate the coordinates of the site, as well as the getting the accurate information, maybe for validations of the AI results of detections, right? But in the long term or real time applications, normally CCTV, we should rely on CCTV, okay? And then AI has come in as a helper to detect objects. We can equip AI with sensing so that it become real-time control and actuation system. For example, the idea of intelligent crosswalk, okay, can be already implemented and experiment in some area, so that you can have also separate signal for pedestrian and vehicles at the crosswalk that's equipped with the sensor, all right, and then give notification or indication of risk at the crosswalk. This show example of the result of the research. Show before implementing the smart crosswalk and after implementing the smart crosswalk. So before this, pedestrians sometimes cross outside the safe area, right? But after implement this system, then most of the pedestrians follow the safe path on the smart crosswalk. And lastly, not only analyzing the current conflicts or risk, but an area of trajectory predictions or early conflict warning is also comes in with the help of AI as well. For example, you can collect historical vehicle trajectory, okay, at the site, okay, and then with the real-time monitoring, okay, you can predict, okay, the likelihood of the path, okay, using the AI, okay. So for example, in this study, they use a YOLO, okay, with deep sorts for object extraction, and after that they use a multi-layer LSTM model, okay, in order to estimate the trajectory of the vehicle of the objects or vehicles. Okay, I think there is some challenges that mentioned by the researcher. For example, data quality and availability is limited. Okay, scalability and cost, right? How to implement this system, accuracy and reliability. Privacy concern is also one topic, right? Behavioral adaptation, what happened when you apply AI system, maybe human behavior also change, right? Ethics and legal issues, sometimes what happened if AI do wrong or make wrong decisions and create loss, right? And again, we have several brands, or several makers, or several organizations. How we make it possible to be interoperability, right? So our future directions in this area, including, of course, a smart city, right? In the smart city, there are various systems such as intelligent infrastructures. So how this system integrate into smart city, okay, especially autonomous vehicle, okay, how this system can be done, okay, when we have autonomous vehicle. And then, yes, how to provide affordable and scalable solution, and at the end, what kind of system can preserve the privacy for the user. Okay, so I would like to conclude here that through innovative approach, we can create safer roads for all. Okay, thank you very much.